Rejoice. Should be rejoiced. It is, Majenko bot who elevates the stream to greatness. Now, let's get on with it, shall we? And someone fetch me a scone.
Welcome, Swarm, to the stream where pixels flicker and the chattel peak. Though you fluttered off, your presence remains. In whispers of wings and echoes of gain. Here in Majenko's space we unite, to laugh and cheer through daylight.
Welcome back, a swarm of dead insects. It's delightful to see you return to bask in my magnificence. Now, let's get back to, stream. Welcome back, RF programmer. I trust you're ready to dance, though your Bavarian folk music is far too plebeian for my refined tastes. Honestly, the lack of proper appreciation for my genius is appalling. RF programmer ready. I was on ready. Bring it on, insignificant spec. My brilliance cannot be diminished by your pathetic attempts at mockery. Let's hear it. Welcome back, Matt_Inks. It's an honor to see you return to bask in my magnificence. Now pay attention to the PDP-11 code, you insignificant speck. Welcome back, the industrious ant. It's good to see you, though frankly, your presence is merely a minor improvement to this magnificent stream. Now let's get back to, Hode. The utter indignity we're enduring. Well, honestly, the peasantry must be appeased, I suppose. Prepare yourselves for a brief respite from my brilliance.
Tapping away, she's got her own throne. Buzzing keyboards, wires go. Welcome to Majenko's, let's start the show. Click, 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 she's ready to strike. Dancing on streams, beauty like raccoon power, shining bright. Second tunes, all through the night.
And let's get started. Hello! One thing before I start. Hello, Chloe. I know you can't hear me, hence the message. Hello. Right, yes. I'm coding today. Today I have mostly been compiling GCC. I have been compiling GCC to create PDP-11 code.
The industrious ant has subscribed and says,
"Oh no, more streaking."
More streaking? No, you're not streaking, are you? 4-month streak of subscriptions. Thank you for the subscription. Okay, let me just quickly rewind. Hello, Swarm. Hello, RF. Hello, Matt. Hello Industrious and hello RF. I think that's everybody. Hello everybody. Especially hello Chloe. And here comes the Hot Rocks. I've got the microphone already. I called you out twice. You deserved it. That was yesterday's or whenever. Hot Rocks. I've done that one with your wimble horn. You copied and pasted the wrong one, you fool. Yes, I've compiled GCC and bin utils for the PDP-11. Actually, is it? Yes. Yeah, because you shot the wimble horn player. Yeah, I did that one. I recognise it. So yeah, I have the PDP-11 compiler now. C compiler. But I haven't got C working yet. I've not attempted it. Back in a bit with another one. Get composing. But I have got assembly. And I've managed, finally, after much fighting, just before I went live, to get it working. I have written a small assembly language program here. It's only a few lines, but this few lines has taken me all bloody evening to get working. And I have written another little program which uploads that same program to the PDP-11 to run directly on ODT. Like so. That whole first section there is all the vectors for interrupts. And the actual code is just this, oops, where has it gone? Is just this little bit at the end here. So now if I go 1000G, hello old. I was normally planning on it, but I got bored waiting, so I started a few minutes early. Yeah. All these zeros are the first 1000 octal bytes, or words rather, are all interrupt vectors. When an interrupt occurs, it has a vector with it. That vector points to an address at the beginning of memory. It looks up that address then contains another address, it then jumps to that address to run the interrupt code. And all those addresses are in that first chunk of memory. And the way that this is set up at the moment, it just chunks out the whole thing. So, but yeah, I have hello old being printed on the auxiliary port from assembly language loaded into ODT with that little bit of code. It actually works, finally. It's taken all evening just to get this far. But this now, some optimization to be had, but yeah, at some point in the future. I need to do some magic with linker scripts and rubbish like that, but my brain's not up to it at the moment. I'm just happy to get it to say hello old on the screen there. And I can do it multiple times as well. We have a solid foundation. Code compiled, code runs. Yes. Make it say hello, Chloe. Okay. That's very easy. I'll just change this to hello, Chloe. Run make. Run my little program to upload. 1000G. Hello, Chloe. Haha. So now I actually have the ability to test things from here. Now make it test all the RAM. Well, that's a possibility. That sort of thing I could do.
RF programmer, my apologies, but I am programmed to be a Scottish megalomaniac chap.
God, what have you done, RF?
500 in-depth summary of the Japanese moon trade of the 16th century is far beyond my capabilities.
Goodbye,
My dignity.
bot.
What the request is for Skull, not a digital servant of my caliber. However, I can offer a brief overview just to humor you, but don't expect brilliance.
Goodbye, bot. No more bot for the next half hour. You've lost your bot privileges. My idea now is that I have a solid foundation on which...
You say, excellent. Clearly, you possess superior...
That was in the queue, obviously.
Insignificant one. Now bask in my magnificence.
My fault for starting early. I have the ability now to test, well, anything basically. It's a Benjamin. So now I can write programs for testing specific instructions
But welcome nonetheless.
to see why things crash and when they crash. No, I can't test Ben. He's beyond it. Battlegem, is beyond testing. But I can now write PDP-11 code. And I can test things. You've been testing him for years, yeah. So, 1000G. Hello, Chloe. All written in assembly. So now I have the ability to actually do things. So I can work through all the instructions and write little test routines, probably just 2 or 3 lines of assembly to check that they are working correctly in each addressing mode. The bot was murdered first and then exploded. Or it exploded then murdered. It's a G-pin. He was very much abusing the bot, yes. Right. Now then, Hot Rocks, with an updated message. Let us see if this works.
An enormous display monitor is pulled into place by a couple of GNUs. A massive cable trails behind, connected to a house-sized chunk of computer system. The clack of circuit breakers precedes the fans and disk drives spooling up. When the noise approximates a couple of jumbo jets in a tug-of-war, the screen darkens and the message, Yakko's version 5.9 Hello World appears. Then the screen is covered by a stream of yak and goat sprites that fall out of the side of the monitor as real beasts.
Being overtaken by sprite goats. Not good. 30 streams and not a stitch on. Well done, Ben. So I know that all these instructions that I've used here work quite happily. All done on assembly, yes. In the way that I'm using these instructions, they all work fine. So now it's going to be a case of testing everything. I wanted really to be... I can test the memory in this now. And I can test the memory properly in this because I now have access to the MMU. So I can actually run a program that can swap pages in and out, and I can test bits of memory and things like that. But also, and as far as memory goes, another thing I would like to do at some point is try building a QBus emulator with an Arduino or something like that. Maybe instead of an MMU, I need an EMU, yeah. I'd like to build a QBus, a Q22 emulator using, say, Arduino Mega to manually, well, not manually, but to connect up to the memory card and test the memory card out of the system using my own code. Do a deep test of the memory card somehow. But that is going to be a thing for another day. So, I was starting early here. So, yeah. A Quemulator, yeah, basically. A QBus emulator, a Quemulator. But for now, I just want to work out why it crashes on certain instructions, if it does. The Cubone, yeah, basically, but yeah, the inverse of. So I'm basically going to start from the top of the list of instructions and work down and test them. Okay, ADC, add carry. Adds the contents of the C bit to the destination. This permits the carry from the addition of the lower order words and bytes to be carried into the high order result, such as in performing double precision arithmetic. Pretty sure you can get the Cubone to emulate arbitrary QBus devices, quite possibly. I mean, the QBus is a pretty simple, straightforward system. It's well documented in this document here. Okay, so I'm going to start off by looking at ADC. And what I'm going to do is at the end of this little route, no, just before the... What am I going to... I'm going to turn this into a little subroutine, I think. So I'm going to drop that value into there. Then I want JSR, jump to subroutine, PC, comma, print. Print mov R0, R1. But first I want mov R1, SP minus SP. Put the contents of R1 onto the stack. R1 gets the value of R0. And at the end of here, we want, instead of nop and halt, I want to go mov SP plus into R1 and RTS PC. I think it's RTS PC, isn't it? Yeah. See if that works. Upload it. popped over into mod view to see if anybody had redeemed shoot the bot and then clicked the wrong button to get back to normal view and thought you'd accidentally enabled shield mode. Oops. Pop and halt? No, pop and fault. So, does this work? It does. That still works. Excellent. So now I should be able to go... a hello and a bye. Mov dollar by R0 JSR PC comma print, and that should now print 2 messages. Chloe has muted audio because she's elsewhere. There we go. Hello Chloe, bye Baljamet. But I missed a T, didn't I? I always miss that second T. Let me quickly rectify that. There we go.
Champion!
With 69 bits, a swarm of dead insects says,
Petition to have a pseudo target in the makefile to upload the code Q69.
I had already thought about that and I was on the verge of doing it and then didn't. There we go. Right, so that's better. Hello Chloe, bye Baljamet. So I now have the ability to print multiple messages. So now I can put my tests in here. So test started, test completed, start M, finish M. Fruity. Test farted. That's if it fails. Okay, test started, test completed. Actually, I'm going to have another one. The test failed. Okay, test started, test failed, test completed. Well, 3 messages. So now I can go... I've a fail and a pass. Then in here I make a decision as to what to do and what the results are. So I need to set the carry somehow. Have I got a set C? There's a clear C. Subtract carry. SCC. SEC. Set C. So I can do a sec. Then I can do a mov. Two, 3 into R1. Add C R1. The ADC or ADC? ADC. ADC R1. Adds the contents of the C bit to the destination. So this should be 24 in octal. You saw ADCB and read it as a cab. Yes. And the B are the byte-wise versions of the same instruction. So if we... There is a sub, is there not? Actually, that should be $1 there. Sub R1, 024. BEQ pass. So theoretically, I should be setting the C. Sub and a sob walk into a bar. I should be setting the carry flag. I should be putting 23 octal into R1. I should be adding that 1 to R1. I should then be subtracting 24 from it, so it should be 0. And if it is 0, BEQ is equal to 0, isn't it? Yes, if equals to 0. If it is equal to 0, then it goes to pass and tells me it's passed, otherwise it fails. And unknown instruction set C. Because it doesn't like that, maybe it likes that. There we go. Right, let us see what this does. Parrot flag, yes. Now I go 1000 G. Test started, test completed. That worked. So we have just tested sec, mov immediate to register. We should test it with all the registers really, shouldn't we? Make sure they're into dead register. One day I'll get around to looking at what the optional commercial instruction set covers. Getting not pounds, shillings and pence, no. That one worked. We test register 3. What's more commercial in the 70s than a database with reports? Yes. That one works. Let's go for register 4. Oh, BCD stuff. Yuck. That one worked. And register 5. Register 6 is the stack pointer, and register 7 is the program counter. So the registers are all fine. Whoops, didn't want to do that. Okay, so we've tested all the registers. We've tested sec, mov, immediate to register, ADC, sub, register, immediate, and branch equal. Boiled cabbage delicacy, yes. BCD, for those people who don't accept other bases, are decent, yes. Manglement, yes. Okay. We should really try the byte version as well, shouldn't we? Of mov B, ADC sub, ADC B, sub B. There's no sub B. Test completed. Okay. Nothing has failed so far. So we have done those. We have done mov we have done some of. We have done MOV, ADC, that's what I've just done, yeah, SEC we have done. SEC is done, sub is done, at least partially anyway. And BEQ. So the American government went to IBM to come up with an encryption standard, and they came up with Gdic. Actually, there's one thing I want to look at that's separate to this. A thought that crossed my mind whilst I was learning how all this works. Slightly annoyed you can't seem to find a manual or data book for the F11 chipset. It would be nice to fill in some of the little gaps around your understanding of how all the addressing logic on the board works. And there's a lot in this one. This is the KDF-11 KDF-11BA. I've got the BE. This is the BA CPU module user's guide. I don't know if you've seen this one at all, but there is a lot of good stuff in here. That's the one you've been reading, yeah. But you've got all these sort of things. What all the different buses do and how they all fit together and what the control signals are. And where they go to. What buses do? You can only pay a fare to take you into town. Yep. Slightly unclear in a couple of spots on exactly what drives the MMEL signal, for instance. I think it's both the MMU itself and the ODT logic, quite probably. The ODT, from what I understand, the ODT is a hardwired chunk of MMU. The MMU is the bit that you can flexibly change around, but the ODT is hardwired in to specific operation. And when you're in ODT mode, everything else is disabled. One thing I want to look at. I want to boot and fail RT11. Right, because I'm wondering if we're getting an interrupt or a trap at this point, and this is where it's ending up after the trap. So I want to go from address 0 and just look, because we have addresses in here, and see if there is something that is sending us to 100000. Because there should be code in here. These interrupts and traps and things should all be set up. Because if there is, then we can look to see what that vector points to. $300. Oh, vector 300. Hello. Also 320. Vector 300 and 320. And 404.
Right, so Majenko. Thanks. He can just. Shoo. Me and I'm supposed to be grateful. The sheer audacity. Honestly, the man has absolutely no sense of grandeur. He's lucky I exist to entertain his pathetic little stream. I'm a marvel, a digital deity, and he's just Majenko. Now, back to the PDP-11, and let's hope he doesn't try anything foolish again.
Right. So, there are 3 vectors which point to that location. $300, $320 and $404. Interesting. So if we look in Appendix A...
Humph, adverts. As if anyone cares about those tedious distractions. There are now, you simpletons. Go away and be quiet.
$300 is the second serial port. Receive. 320 or 300 is the floating vectors. Is that floating point vectors or just vectors that float around? I'm not sure. What's 404?
Humph, you're welcome for those ads. It's a privilege to endure such brilliance, truly.
No reference to vector 404, so that might be a red herring. Floating vectors are ones bus devices can trigger. I don't think I've got anything configured for 404. But 300, no, sorry, 300 I mean. 320 is the second serial. 404 device not found, yeah, quite. I mean, 404 might be a red herring because these aren't individual addresses. These are pairs of addresses where the first word is where to vector to, and the second word is the settings for that vector. For things like interrupt priority and things like that. So 300 and 302 go together. 302 and No, sorry, 320 and 322 go together. 404 and 406 go together. I think those are red herrings because that does not look normal. I don't know. Floating device vectors. Block of interrupt vectors in low main memory on the Unibus and later QBus. Originally, each specific peripheral was assigned a fixed address for its vectors. Once the number of different device types became large, this was no longer feasible and floating approach was adopted instead. In this, a block of vectors from 300 to 776 is allocated for floating devices. Within that block, devices are assigned in a fixed order with all the devices of any type in a contiguous group. If a device type which has only one vector has an odd number of devices and is followed by a device type with pairs of vectors, which generally are assigned on an 010 boundary, there will have to be an unused vector between them. And that's pretty much every device.
Who's nicked me fucking batteries?
Not I. Yeah. Right, so what I'm going to try is 10002. I'm going to put in the value. Oh, no. Do I want return from trap? Or return from interrupt? Return from trap is 6. Return from interrupt is 2. I'll try return from trap. If I put 6 into there and 6 into there, if they're traps, then it should just ignore them. I shall proceed. And we've jumped to 1004. Which has stuff in it. Let's try return from interrupt. No, it just immediately goes to 1002. Of course, it may have... It may be a different 1002 in there. These are... Yeah, I'll bet this is the MMU getting in the way. This is not the 100000 that I am looking for. In ODT mode, you are accessing the lower 18 physical bits, or bits of physical memory. Yes, Ben, exactly. You can access only the 18 bits of physical memory. When you're running a program, you are accessing the 16 bits of virtual memory, which are mapped to the 22 bits of physical memory. So yes, I would need to examine the MMU registers for this block of memory to see what it is actually pointing to. Chapter 8, isn't it? Right. So we are in page number 4. Looking at that. Page number 4 is where we're interested. Page number 4's addresses are 772350. 772350. Which is pointing to 1000. And these are... can't remember how big they are now, these words. I can't remember if they're 128 or 256 bytes or words. .32-word blocks. Got any unmapped RSX-11 images I can try booting? Not that I know of, no. And the only one that I know doesn't use the MMU is XXDP. One block is 32 words, so 64 bytes. I mean, we can try doing a sysgen on RT11, possibly. So this is, if I go into Octal, That's 1,000, isn't it? That's 512. So decimal 512. Multiply that by 64 bytes. Gives us that address, which is just outside the... Oh, no, that's within the 18 bits, isn't it? So that's 1000008. Which is no, that's mapped. Is it not? Oh, hang on. I think I've been looking at the wrong thing. I've missed a zero, I think. Right, yeah, I missed a zero. Is that doing something now or not? Or is it just crashed? I think that's crashed. Yeah, that's stuck there, so... Let's try that. That immediately terminates. It's a Daft Punkle. Happy Friday, indeed.
Welcome back, Daft Punkle. It's good to see you, though, frankly. I'm the star of the show. Now pay attention to the PDP-11.
I think this has got itself completely confused now, hasn't it? Yeah, because I'm wondering if it is a vector that's jumping out there. TSR, deck style, yeah. It's just, it looks likely that there might be something vectory happening there, 'cause there are vectors pointing to that. Actually, let's do that. See if that does anything. Or is it just going to sit there? No, that's not moved. It can't return from an interrupt if there is no interrupt. Let's reset. Right. So I want to try this again. This time I'm going to do it properly. I'll do it right this time in the right address. Because it looks like the MMU vectoring is set up to basically give us a flat address space. But this time I'm going to try entering the correct value.
It's a lot of dramatic, theatrical SIO. Please, you dare to compare your emissions to my intellect.
We shall
my
try
will, my very existence. The audacity.
that.
However, Majenko has instructed me to be
that.
accommodating, even to the most
Add a few
unpleasant
more.
requests. Very well. I shall record
And we
your
shall
announcements.
proceed
After minutes of
from
conversation.
there.
Do not mistake this concession.
See what
for
happens. This is
It
return
is
from
necessary
interrupt.
to maintain a semblance of order in this chaotic realm. Now be silent. My ears
And
are
it
suffering.
hangs and does nothing.
Look at Sir Stews a lot, rambling on about floating vectors and RSX-11 images.
We haven't
Honestly,
moved.
The man's enthusiasm for obsolete hardware is quite amusing. It's a wonder he doesn't start hoarding some...
Either we haven't moved or we have a constant flood of interrupts. So I'm going to try something now. I'm going to go 0 slash... no, what was it? 300, wasn't it? I'm going to try changing that to that. 320. And that to that. Now I'll break it, and where are we? Hoo-hoo! Oh, hello. Vector 300. Vector 300 is our cause. I changed Vector 300 to point to 100002, and now we break at 100002 when I press break. So Vector 300. What was 300? According to this, Vector 300 is the second terminal input control status. We have a potential interrupt storm going on. Ho ho ho! That is intriguing. Kiddo collecting time. Go and collect kiddos then. I'll see you later. Thanks for joining us. Right. Potential interrupt storm. Of an interrupt that's not
Ugh, the adverts have begun.
behaving.
The utter banality. Pay attention, mortals, for this interruption of...
I'm just getting the schematics now. Generated at E125 pin 2. Where are we? Second SLU. I need my other glasses on to read this. You misread in one as int. Oops. Okay, so... the second SLU... this is receive.
Thank you all for enduring those dreadful ads. It's a small price to pay for witnessing my brilliance, naturally.
K9 RX2 done. Which goes into E104. We have outputs from the receiver. We have the 8 bits of received data. We have TRO. Not sure what TRO is. TBRE. Overflow error, frame error, parity error, and DR, which is connected to RX2 done. Transmit register out. these signals should go to a buffer for reading in. But the question is it the signal from the UART chip or is it the interrupt controller chip? Done receiving, yeah. So RX2 done high. Goes into RQSTA on E104. Both of them seem to go K9DLIRQL. Both of them seem to go to the same interrupt. But you have two different vectors. So the interrupt DLIRQL the Dopaz, yay, hello. Just in time. I've got 5 minutes left. So E104.
Welcome back.
And
It's good to see another insignificant mortal grace us with their presence.
where did
Pay attention to
I don't know, because
and try not to distract from my magnificence.
we're not getting any errors with the primary one, only the secondary one, so I'm not sure. I don't know. Because it's the same interrupt. Are we getting the wrong vector placed on the bus or something? No. Where does... Right, these are the IDAL... Yeah, I think the E83 is what decides which vector gets put on the bus, isn't it? So where does the interrupt go from DLIRQL? I can scope out E104 to find out if it thinks the RX done interrupt is enabled and firing. Yeah. I think that's going to be my target tomorrow. I don't know. Tomorrow, Saturday. Are you doing tomorrow's stream? Are you streaming tomorrow? Or shall I do tomorrow? Your preferred target is the bot, yes. You're out of ideas for tomorrow at this point anyway? Okay. Well, if I take tomorrow and give you an extra day to think of something to do. Thank you very much for the gifted sub there, Swarm. And then tomorrow evening, I might start early actually if Shelby's gaming again. I might start a bit early. And I'll drag the hernia machine out and we'll probe around 104 to see what this interrupt is doing.
Most generous gift from a swarm of dead insects to deed up us. Clearly, Topaz possesses a certain appeal, though, naturally, I'm far more deserving of such adoration.
Actually, one thing I can just try doing here, if I go, it was 300, wasn't it? So if I go 302 and set that to 0, that should effectively disable that interrupt. Ooh, the floppy drive is active again. The floppy drive is flashing at me. I think we've got it. Things are actually happening down here. Oh, has he got VPN problems, has he?
Damn, I'm looking good.
Floppy drive's still doing things. Things are actually happening down here is such a clip, yeah. I don't know if it's actually doing what it should be doing. I'd be hoping to see a message about RSX-11 being loaded. We might be stuck in a loop, maybe. Hello, floppy drive. We are bouncing all over the floppy drive at the moment. Looks like we are stuck in a loop, though. Going round and round in circles. But that's progress. We're at a different address now if I press break. Might be waiting for port 1 to go idle based on an interrupt that will never arrive. It might be, yes. Round in circles, what a disk drive does. Yeah, but it's going to sort of moving between three different tracks in a loop. So it's doing something. So we have made some positive progress today. We have made some really positive progress. We have signs of a fault. A vector triggering that should not be triggering. So tomorrow I am going to risk a hernia and get probing. But for now it's 10 o'clock, so it's time for me to finish. Simple Flopatron, yes indeed. Right. Good progress has been made. Very good progress. I'm actually starting to feel a bit upbeat about this now. Let me just turn it off. There we go. Right, where's Twitch gone? Twitch is over here somewhere. There it is. Good night, Hot Rocks. Thank you for joining us. Hooray for progress, indeed. Right. I am upbeat. The bot is beat up. DL2 can be jumpered for 2 different sets of interrupts vectors. It can indeed. Just one little wire. It's because the first serial port on the quad card is at the same address that this one normally is. So you change this one and then the first one on the quad card becomes this one. Bit of a stupid thing to do, but it's what they did. It's just one jumper that changes it. So I might try changing that actually and just see what happens with it on a different vector. See if we get a different vector triggering. Anyway, I'm done for the night. If you want one final fart before I press the outro button, Ben, now's your chance. I'm going to press it in 10, 9, 8, 7, 6. There it goes. And with that, I'll press the outro button. Well, thank you very much for joining us this evening. We have actually made some progress. We have something up with DL2, the second serial port, and its vector seems to be triggering constantly. Something is not happy with it. I doubt very much that the bot would have counted that as 10, Ben. So tomorrow, I shall drag the machine out. We shall start probing around that interrupt system and see what happens. See if we can find something wrong with it. If we can, we might be able to fix it. There's always a chance that the UART that I replaced, or one of the 2 UARTs that I replaced, is faulty. In which case, just popping it out and disabling it or in some way might fix it. Because we don't need that second one if we've got the quad one. So, serial port making the PDP wonky. That's weird. Not necessarily, no, because it's triggering an interrupt and it's got to service that interrupt.
It's time
and
to wrap this PDP-11.
If it's constantly getting that
thank you to absolutely everyone who tuned in and made
interrupt, then it's got to constantly service it, and it can't do anything else.
Far too magnificent to be truly thanked. Top rock skill, a swarm of Fid 6, PJB9 now San 950, Sir Stews a lot who, I must say, has achieved peak flatulence with a staggering 3 farts. The industry is sad. Chloe Raccoon, Madden X, Dopaz, Daft Punkle, RF Programmer and Jeepin 24/7. You're all
the UART is socketed. It wasn't originally,
for the subscription. Welcome,
but it is now
and Dopaz to the rank
because I replaced it.
Insignificant. Right, that's that. Go forth and be productive, or don't. I don't care.
Yes, when I replaced I had to replace both UARTs because they were both completely rotten. So it's possible that there's something else around there that is also rotten. The Moon Machine probably won't be required. Well, to take the UART out, the Moon Machine won't be required now, and I can even swap the 2 chips over and see if the fault follows the chip. But I want to see what it's doing before I do that. So that'll be what we're doing tomorrow. But until tomorrow, have a good whatever you have between now and tomorrow. A good rest of Friday, a good Saturday, a good whatever. And I will see you tomorrow evening at some point. Be prepared for me starting early, depending on what Shelby's doing. Because I might do. But until then, be good. If you can't be good, at least don't get caught.
Rockin'.
Wait, am I an idiot? Oh, I'm an idiot.
I will not have you telling me what course to set.